Hello my dear students, good afternoon. Welcome back for the next lecture. We were doing application of Gauss's theorem. Today we will do the third application. In this we have to find electric field intensity due to an infinite thin sheet of charge. So we will take today electric field intensity due to an infinite thin sheet of charge. Not thin. You can have thin or thick. Conducting or non-conducting. So first we are taking thin and conducting sheet of charge. So let us consider here. Let us consider a thin sheet. So this is a thin sheet. This sheet is towards you. This edge is towards you, and this is the back side. And say it is uniformly charged, and say it is uniformly positively charged. Now, मैंने पहले पिछले लेक्चर्स में बताया है कि दिस शीट हैज ए एरिया. तो अगर एरिया है तो चार्ज कैसे डिस्ट्रीब्यूट होगा? चार्ज इसके पूरे सरफेस पे डिस्ट्रीब्यूट होगा, एंड वी हैव टू टेक इट्स सरफेस चार्ज डेंसिटी. तो इस शीट का डेंसिटी कौन सी होगी? लीनियर नहीं होगी क्योंकि इट्स नॉट लेंथ. वॉल्यूम भी नहीं होगी क्योंकि चार्ज इसके सरफेस के ऊपर, एंड इट्स वेरी थिन. तो वी विल टेक इनफाइनाइट लॉन्ग. सी, this is infinite. It is extended to both sides up to infinity. This side से भी, इस side से भी. It's a very big sheet, but it's very thin sheet. तो इसके surface charge density क्या होगी? It is sigma coulomb per meter square. So let us consider an infinite long thin. This is thin and conducting sheet. If it is conducting sheet, the charge uniformly distributes over its surface, and it has a surface charge density sigma coulomb per meter square. See, we have sigma. Now what we have to do? We have to find the electric field intensity due to this sheet at a point P. Say this is a point P. This is a point P, और इस point पे हम electric field intensity निकालना चाहते हैं, जो इसके कितने डिस्टेंस पे है? प्रोपेलिंग डिस्टेंस कितना है? Let it be R. This point P can be taken here also. कहीं भी ले सकते हैं, but we are taking it here. Now what's the distance of this point from this sheet? It is at a distance R. अब see here, this sheet है, for example, this is a plane sheet. Electric field lines कैसे होंगी? इस साइड और इस साइड. I am drawing few of the electric field lines. These are the electric field lines. इस साइड भी होंगी शीट के. These are the electric field lines because of the sheet. It is a positively charged. It is a, you can say, outwards. That side and this side. So what we have to find? We have to find the electric field intensity at point P, which is at a distance R. यहाँ से यहाँ distance कितना है? R. So what type of spherical Gaussian surface will we take? No, see, spherical तो हो नहीं सकता. तो we will take a cylindrical Gaussian surface. Now cylindrical Gaussian surface भी कैसे लेंगे? We can take a parallelepiped also. We can take a cuboidal surface also. Cylindrical is much better and easy to take. So let's take a cylindrical Gaussian surface passing through point P. Now कैसे लेंगे वो? We'll take like this. Say this. This is cylindrical Gaussian surface. इसका back side है, इस side भी जाना. So this is a cylindrical Gaussian surface, and it encloses this much portion. So we are taking a cylindrical Gaussian surface. See here. Now we will apply Gaussian theorem to here. Now why we have taken such type of Gaussian surface? ऐसे हम ले नहीं सकते क्योंकि it is extended both sides to infinity. ऐसे भी नहीं ले सकते because उस साइड से भी infinity की तरफ extended है, इस साइड से भी extended. So there is only one possibility. We will take this type of cylindrical Gaussian surface, and this point is P. This is on its circular cap. So before I rub it, see here, what we have taken? We have taken a sheet having a uniform surface charge density sigma coulomb per meter square, and this is a thin and conducting sheet, and that P is a point in the distance pair. This is distance is R from the sheet, and हमने कौन सा Gaussian surface लिया? We have taken a cylindrical Gaussian surface. This is cylindrical Gaussian surface S. Now let's apply Gauss's theorem. Let's apply Gauss's theorem. What Gauss's theorem says? Apply Gauss's theorem. Surface integral closed surface integral of electric field over a surface ds is equals to 1 upon epsilon naught times the total charge enclosed. Now see, again we have three surfaces here. Curved surface, this cap and this cap. This point P can be here, this cap it can be here also. Again we have three surfaces. Let's take the first surface like this, S1. Let's take this as S2, and the curved surface as say S3. So we are dividing the surface as into three. This surface that is S1, this surface that is S2, and this is what come circular surface. This is also circular, and this is curved. This is curved surface. तो हमने डिवाइड करना है इसको तीन पार्ट्स में. अगेन पहला कौन सा है? S1 E डॉट ds1 प्लस S2 E डॉट ds2 प्लस S3 E डॉट ds3 equals to 1 upon epsilon naught times total charge enclosed. We can write Q enclosed ऐसा लिख सकते E and C, that is charge enclosed. Now see here, let's take surface elements. Let's take, this is a surface element. This surface element is ds1. Where is the n cap? This is the direction of n cap. Where is the electric field going? Electric field is going also along with n cap. Electric field कैसे जा रही है? हमने electric field पहले ही draw किया. n cap भी surface पे उस साइड जा रहा है, तो what is theta here? 0 degrees. तो यहाँ हम 0 लिख देंगे, cos 0. Let's come to here. अगर हम यहाँ surface लेते हैं, let it be ds2. इसका n cap कहाँ होगा? इस साइड होगा. Electric field कहाँ आ रही है? इस साइड आ रही है. So what is theta here? Theta again here is 0 degrees. उस साइड भी और इस साइड. Now third surface. Let's take a surface here. For example, यहाँ ले लेते हैं. थोड़ा part is outside है. Remaining part. This is what? ds3. Where is n cap? N cap is upwards. Where is electric field? Electric field is this way. What is the angle here? Theta equals to 90 degrees. कोई यहाँ भी ले सकते हैं. Anyway, this point can be taken here also. तभी एंगल कितना रहेगा? अगर आप यहाँ ले लेंगे तो n cap नीचे आ जाएगा, इलेक्ट्रिक फील्ड साइड आ जाएगी, थीटा कितना आएगा? अगेन 90 डिग्रीज. तो कॉमन सेंस भी इलेक्ट्रिक फील्ड अगर ऐसे जा रही है और ऐसे जा रही है तो it will cut which surface? It will cut this circular surface and this surface. It will not cut the curved surface. It will touch the curved surface only. Curved surface है cylindrical surface है जो curved, उसको touch करती हुई निकल जाएगी. But electric field line cut किसे करेगी? इस circular surface को और इस circular surface को. And let's the area of this circular surface be, let it be A. So what's the area of this? A. What is the area of this surface? A, which is equals to pi r square ले सकते हैं, but we are not taking pi r square. Why? Because we have taken the distance r here. Let it be A. So let's do S1 mod of E ds1. What is ds1? Here it is ds1. What is theta here? Cos 0 degrees. S2 E mod of ds2. What is ds2? Here this is the second surface. What is theta here? 0 degrees. We'll write cos 0 degrees plus S3 E mod of ds3 cos. Which is the third surface? The curved surface. Either this or this. What is theta here? 90 degrees. And we will do it later on. What is cos 0? Cos 0 is 1. Cos 0 is 1. Cos 90 is 0. So we are left with only two integrals. E ds1 plus again E ds2. I am not writing E1 and E2. Why? Because the distance here and the distance here is the same. The electric field will also be same here and here. That's why we are taking E and E here. Take E outside. We can take E outside. So we'll do it later on. Let's take this side also. 1 upon epsilon naught. What is the charge enclosed? इस पूरे Gaussian surface में कितना charge enclosed है? Charge enclosed is only this much. See here, this much portion. And since it is a thin sheet means only one layer of charge is there. एक sheet है जिसमें सिर्फ एक ही layer है. For example, this is a sheet, metallic sheet. If it is very thin, तो charge जो है, it is only one layer. इस side से भी और इस side से भी एक ही layer का charge है. तो we'll take this portion. So this is the charge, positive. And what is the area of this? Obviously, area of this is same as A. जैसे इसका area है, इसका area. So what is the area of this portion? It is A. So since the sheet is very thin, so it is considered as a layer of single charge. So उस side पर उसकी electric field जा रही है और इस side भी आ रही है. So we are taking it. What is Q here? Q enclosed. Q enclosed कैसे निकालेंगे? We have a surface charge density. What is surface charge density formula? Charge upon area. So if I want charge, so what it should be? Sigma into A. So what would we have? Sigma into A. Once again, what is charge enclosed? Charge enclosed is this much portion. And what is ये कितना charge होगा? Charge density into area. Charge density, what is this charge density? Charge per unit area. इसका एरिया कितना है? A. तो फिर इसका चार्ज कितना होगा? Sigma into A. Otherwise, we have a formula sigma equals to charge per unit area. So what is charge? Charge equals to sigma into A. So put it here. तो ये कितना आएगा? Sigma A upon epsilon naught. So before I rub it, see once again. Apply Gaussian theorem. This is the Gaussian theorem. Divide the surface into three surfaces. We have one surface here, second surface here, third is the curved surface. These are the curved surface. Here theta is 0, theta is 0, theta is 90. Here we have theta 0, theta 0, theta 90. Cos 0 is 1. This is cos 0 is 1. This is cos 90 is 0. The third integral becomes 0. So who is contributing to the flux? Only the circular caps. This cap and this one. Curved surface area is not contributing to any flux. We are left with two integrals. And what is the charge enclosed? Charge enclosed, if sigma is the charge density, तो sigma equals to क्या होता है? Charge per unit area. So if you want a charge equals to sigma into A. Sigma into A. What is this A? This A is the area of the circular caps. तो ये area और ये area और ये area same ही है. So sigma into A. Now see here. See, इसमें से we can take electric field outside क्योंकि it is considered as constant. Take electric field outside. S1 ds1 plus this electric field also outside. S2 ds2 plus sigma into A equals to sigma into A upon epsilon naught. Now what is ds1? This is ds1. So हम integrate करेंगे, what do we get? The whole area A. E into A. This E into A. What is ds2? This is ds2. What is the integral of this? It will give this area. Circular area. EA. अगर आप पैरेलल पाइप ले लें, पैरेलल पाइप कैसे होता है? पैरेलल पाइप is just like a cuboid, like this. हम ये भी ले सकते हैं. Instead of this, so we will take this as an area, this as an area. The answer will be the same. हम ये भी ले सकते हैं, but cylinder is much better. So EA plus EA equals to sigma A upon epsilon naught. So that gives rise to 2 times EA. That is equal to sigma A upon epsilon naught. A and A cancels. What is electric field equals to? The electric field is equals to sigma by 2 epsilon naught. Very important relation. And this is because of the thin sheet. This is because of thin sheet. See here, electric field is sigma by, it is independent of R. It is independent of R. मतलब distance से depend ही नहीं कर रही है. इसका मतलब it will produce a uniform electric field. Electric field strength same ही रहेगी. और uniform electric field कैसे represent करते हैं हम? Parallel line से. So this give rise to a uniform electric field. ऐसे electric field produce करें. इस side भी और उस side भी. It is independent of R. See, there is no R. And it only depends upon sigma. What is sigma? Surface charge density. This is the scalar form. And greater the surface charge density, greater will the electric field. अगर surface charge density ज़्यादा होगी, अगर इसमें charge ज़्यादा dense होगा, तो electric field भी ज़्यादा strong होगी. And it is constant throughout. Its side pure, it extends, it goes to infinity. So this is the expression for it. अगर आप वेक्टर फॉर्म करना चाहते हैं तो वेक्टर फॉर्म में क्या होगा? वेक्टर फॉर्म में in vector form, it's very simple. We'll put a E vector sigma upon 2 epsilon naught and R cap. This is in vector form. The vector form में क्या होगा? Electric field radially outwards होगी. If sigma is positive, it is radially outwards. If it is negative, it will be inwards. This is the vector form and this is the scalar form, and this is the electric field because of a thin sheet. Thin sheet. Now let's do a special case. If the sheet is thick, it is not thin, it is thick and conducting. तो क्या होगा? तो let's do. So I'm rubbing it. Before rubbing it and telling you again, इसमें से ये कंट्रीब्यूट कर रहा है, वो कंट्रीब्यूट कर रहा है फ्लक्स को, कर्व सरफेस एरिया कंट्रीब्यूट नहीं कर रहा है. We have left with only two surfaces, EA plus EA. What is A? Area of this surface and area of this surface. We can take cylindrical Gaussian surface, or you can say parallelogram. Area will be the same. It is 2 times EA, sigma A upon epsilon. EA cancels, we get this expression. And this is for the thin conducting sheet. And this expression remains the same for thin insulating sheet also. Answer will be the same. Now let's do for a thick sheet. What happens if the sheet is thick? And thick conducting sheet. Thick conducting sheet. For thick conducting sheet. See here. Special case, thick conducting sheet. It is thin this is thin. So thick conducting sheet can, I am making a diagram. It would be like this. See here. ये ऐसे थोड़ा मोटी है. So this is thick. This is thick, and it is conducting. Thick conducting. So you will find on conducting sheet the charge only resides over its surface. The charge इसके surface पे ही रहेगा, इस side भी और उस sheet पे भी रहेगा. And what is surface charge density here? Same, sigma coulomb per meter square. इसकी भी surface charge density कितनी? Same ही है. The only difference is that it is thick. तो इस side भी है charge इसका है. I'm not able to draw it here, but this is this face. इस side भी है. So what is the charge density? Sigma coulomb per meter square. So this is the point. This is the point. Again, we will draw two surfaces. Now see here, what's the difference here? Everything will be same, but the charge enclosed is here 2 times. This one and जो sheet के इस side होगा, sheet के इस side भी और इस side. Again see, अगर ये sheet thick होगी, तो we'll take this charge as well as this charge. If it is thick, it is not single layer charge. And charge इसके बीच में, if it is thick, if it is conducting and thick, इसके अंदर चार्ज कितना रहेगा? 0. बीच में 0 रहेगा. The charge only resides on the surface. इस पे भी चार्ज पॉजिटिव और इसके उस साइड भी चार्ज कितना है? पॉजिटिव, और इसका भी एरिया A है, इसका भी एरिया A है. तो we have, वो तो वही रहेगा EA plus EA. These two both are contributing to the flux. What is the charge enclosed here? Earlier it was sigma into A. Now we have sigma A this as well as sigma A this. So we have 2 times sigma A. We have 2 times EA here, and we have 2 times sigma A here. Again see here, why 2 times sigma A? This is the charge of this side, and this is the charge of this side. This is sigma A here and sigma here from that side. Since क्योंकि ये sheet कौन सी है? Thick sheet. This is a thick sheet. तो इस साइड भी चार्ज है, इस साइड भी चार्ज है, और क्योंकि ये कंडक्टिंग है तो इसके अंदर चार्ज नहीं होता. चार्ज ऑलवेज रिसाइड्स ओवर द सरफेस ऑफ ए कंडक्टर. तो 2 cancels, A cancel. What's the answer? E equals to sigma by epsilon naught. See, this is for thick sheet. This is for thick sheet. तो thick sheet के लिए we have E equals to sigma by epsilon naught. What was the expression for thin sheet? We have sigma by 2 epsilon naught. What we have found? If it is thick sheet, तो thick के लिए तो ये I am writing here thick. If it is thin, I am writing here thin. Sigma by 2 epsilon naught. So it will be E thick divided by 2. तो थिन शीट की इलेक्ट्रिक फील्ड थिक शीट के कंपैरिजन में हाफ रहती है. इसकी इलेक्ट्रिक फील्ड इसके कंपैरिजन में हाफ रहती है. तो व्हाट इज द, हाँ, इलेक्ट्रिक फील्ड की डायरेक्शन सेम रहेगी. इट इज अगेन इंडिपेंडेंट ऑफ द डिस्टेंस. बट व्हाट इज द मैग्नीट्यूड हियर? सिग्मा बाय एप्सिलॉन नॉट. हियर और हियर इस साइड भी वही रहेगा. E इक्वल्स टू सिग्मा बाय एप्सिलॉन नॉट. बट व्हाट इज द मैग्नीट्यूड हियर कहीं पे भी लेंगे तो what is the magnitude here? Equals sigma by 2 epsilon naught. And here also we have, यहाँ लेना चाहते हैं, we have E equals to sigma by 2 epsilon naught. This is a thin sheet, thin conducting sheet. This is thick conducting sheet. So we have two expressions: sigma by epsilon naught for thick, sigma by 2 epsilon naught for thin, and both are independent of the distance, and both are conducting in nature, and both produces uniform electric field lines, and uniform electric field lines are represented by parallines. We will take those special cases also in my further lecture of these two things. These two sheets combines to form a capacitor. One positive charged sheet, another equally negatively charged sheet combines to form a capacitor. We will do it later on. But for today's topic, we have done electric field intensity due to the infinite long or infinite thin sheet as well as thick conducting sheet. That's all for today.